Hello, my name is Muhammad Laik and welcome to my video. Today we will discuss an advanced topic called meta modeling. Now let's discuss the table of contents. In the first part, I will give some brief introduction in terms of definitions of meta model. Then I will discuss the representation and conformance. In the third part, I will discuss the four meta modeling layers with some examples. In the fourth part, I will discuss meta modeling and semantic domain in real life. And in the last part, we will conclude that what we have learned in the whole video process. So let's start our first part. In the first part of definitions, first of all, I will explain some Google definitions. Then I will explain some authorized UML definitions of meta model, and then finally I will discuss some authorized MDA definitions of meta modeling. Now let's see that what Google says about the meta modeling. So according to Google, meta modeling is the analysis, construction, and development of the frames, rules, constraints, models, and theories applicable and useful for modeling a predefined class of problems. According to another Google definition, a meta model typically defines the languages and processes from which to form a model. Another MOF standard definition says that according to the Meta Object Faculty standard, a meta model is a model that defines the language for expressing a model. Also, meta model is model that serve for explanation and definition of relationships among the various components of the applied model itself. So, according to UML definitions, a formal definition of a common MOF based meta model that specifies the abstract syntax of the UML. The abstract syntax defines the set of UML modeling concepts, their attributes, and their relationships, as well as the rules for combining these concepts to construct partial or complete UML models. Another definition of UML says that a specification of the human readable notation elements for representing the individual UML modeling concepts as well as the rules for combining them into a variety of different diagrams through corresponding to different aspects of modeled system. If we see the MDA definition, a meta model is a special kind of model that specifies the abstract syntax of a modeling language. It can be understood as the representation of the class of all models expressed in that language. Meta models in the context of MDA as expressed using MOF. So, after a brief introduction in terms of different definitions, now let's discuss the representation and conformances. We can say that a model is a simplified representation of a certain reality. Now, if we take an example of a map, we can say that there can be many different maps of same territory, but it depends on the purpose. So we can say that somebody needs to riding a bike, maybe someone needs to visit the museums, or maybe someone wants to visit a zoo or driving a car, etc. Now let's take the example of house, and we have different models with their different views. For example, electrician have its own view, and architect has its own view, and the person who is a renter can have its own view. Particularly, a model is focused in one particular aspect of a system. A model is not intended to capture all the aspects of a system, but mainly to abstract out only some of these characteristics. A system is usually represented by a set of different models, each one capturing some specific aspects. Which aspect to capture depends on the purpose of the model. Now let's discuss the two basic metamodeling relationships, in which at the very basic level we have the system, then model, and then metamodel. Actually, a model represents a system, and then that model conforms to a metamodel, because a model is a simplified representation of a certain reality. Now let's move to our main part, which is the four layers of metamodel. We usually say it 3 plus 1. So I'll explain that why we say that. In the basic level, which is M0, the M0 layer is the original system, the real system. So at M1 level, a model represents this system, so which is being represented by a system. So this model conforms to its meta model, which is being defined at level M2. So the meta model itself conforms to the meta model at level M3. And now we clearly can see that the meta model conforms to itself. As we know that a meta model is a special kind of model that specifies the abstract syntax of a modeling language, and it can be understood as the representation of the class of all models expressed. Now let's see it more deeper. As usual, the system is on the basic level, and a model conforms to a language whose abstract syntax is represented by a metamodel. Transitively, we can say that a model conforms to a metamodel. Well, the represented by and conforms to relationships are essentially different. So arranging them in the same direction may be little bit confusing. Well, we can see that the metamodel substitute the modeling language in the transitive conforms to relationship. Now, a metamodel conforms to a language whose abstract syntax is represented by a metamodel. So, transitively, we can say that a metamodel conforms to a metamodel, and then the metamodel substitutes the metamodeling language in the transitive conforms to relationship. So finally, a reflexive meta model conforms to a language whose abstract syntax is represented by itself. Transitively, we can say that a meta model conforms to itself. The meta model substitutes the meta modeling language in the transitive conforms to relationship. Now, let's discuss a real quick overview of meta model and semantic domain. So, a semantic domain is focused on certain entities and aspects of the real world in which we are interested, maybe excluding others. Well, the selection of relevant entities and aspects is driven by our modeling purpose. We can say that the semantic domain is an abstraction of the real world, like a representation or a model, etc. Well, the semantic domain is a closed world of concepts and relationships, and the meta model gives names to these concepts and relationships, but the meta model gives no meaning and no interpretation. Now, let's move to our last and final part, which is conclusion, that what we have learned so far in this video. The two basic meta modeling relationships, in which we see that a model represents a system and conforms to a meta model. A meta model is a special kind of model that represents the abstract syntax of a modeling language and conforms to a meta model. We saw that the represented by and conforms to relationships are essentially different, so arranging them in the same direction may be confusing. We saw that a meta model is closely related to its semantic domain, because a semantic domain is a conceptualization of some part of the real world, and a meta model gives name to the concepts of the semantic domain. So we see the examples, the two level modeling paradigms. So that's all from my side. Thanks for watching the video. Goodbye.